Hello everyone and welcome back. I'm Mahnur and today we will be diving further into some more conceptual questions of AS level physics kinematics. Now so far we have understood some basic fundamental quantities when it comes to this chapter. Moreover, we have also understood how we can draw out and interpret the graphs of kinematics. Now that we've gotten all of that out of the way, we're ready to see how we can apply the Suvat equations to different kinds of questions. Equations. Now, before we can dive into those kinds of conceptual questions one after another, we should first review what do these equations entail. We remind ourselves that these Suvat equations basically represent a set of equations that we apply for motion, wherein the object is moving with constant acceleration. In that sense, the term Suvad is nothing but a word that's made up of the five quantities that we encounter when it comes to the equations of motion. S is displacement, U is initial velocity, V is final velocity, A is acceleration, and then finally T is time duration. I'll in fact list them out here since these will be useful for later on. S is displacement, U is initial velocity, V is final velocity, A is that constant acceleration, and then finally T is time duration or time spent. The equations of motions themselves, there were four in total. Those were V equals U plus AT, S equals half times U plus V times T. Then you had S equals UT plus half AT squared. And then finally you had 2AS equals V square minus U squared. Now at this stage, you might encounter all of these amounts of equations, and then you might get confused where you might think that, okay, if I'm given a question, how do I know which equation? Now at this stage you might be wondering that now I have such a huge variety of equations to choose from. So during my examination, how do I know which equation to use? How could I be sure that this particular question requires one of these equations? To avoid confusion, it helps to kind of separate each of these equations based on what letter they're missing. So if you notice, the first term doesn't contain a number for displacement S. So the first equation V equals to U plus AT you can use when displacement is not given. Similarly, in this second equation, we find that we don't really see acceleration A appear. And so this equation we can use when acceleration is not given in the equation, or in the question I mean. As for this third equation, we can see that it doesn't contain any expression for final velocity V, and so this equation we can use when V is not given. And then finally, this last equation doesn't contain a symbol for time t, and so this equation we'll use when that time duration is not given in the question. So the approach that we'll follow is basically reading the question, seeing what information is given, then seeing what piece of information do we wish to find as per the question. And then we'll see, based on what we have and what we need to find, we'll choose any one of these equations. So let's proceed with some practice questions and see what kind of questions we can encounter based on which we can use any one of these equations. Alright? Now let's look at our very first question. Suppose we have Tufi standing right here on level ground like this, and let's suppose he's set in motion with an initial velocity of 2 meters per second. Now suppose he maintains a constant acceleration of 4 meters per second square. Now our question is this: in about 10 seconds, what should his final velocity be? When it comes to questions like these, it always helps to know what information is given and know what question or what quantity do we have to find. In terms of the quantities that are given to us, we have the initial velocity u, the acceleration a, and the time duration of acceleration t. And what we need to find in this case is the final velocity v. As far as our four equations of motion goes, there's only one equation that relates v, u, a, and t with each other. That is v equals u plus at. And notice how we were able to shortlist what equation we can pick from the four that we presented above, just by knowing what we are given and what quantity we need to find. Now it's just a matter of plugging our values inside, in which case we get v equals 2 plus 4 times 10, and solving this gives us 42 meters per second. Great. Now let's move on to the next question. Now let's suppose we have Dr. Sal right here seated in a trolley that's moving with an initial velocity of 50 meters per second. And let's suppose he's on this kind of a track that's shown here. Suppose that he undergoes uniform deceleration or constant deceleration in such a way that after some time he reaches a final velocity of 0 meters per second, meaning he has decreased his speed up to a point that it's now stationary. 0. Now, suppose that during this portion of uniform deceleration, Dr. Sal covers about 100 meters of displacement. The question is that how long does it take for him to decelerate until he completely stops and becomes stationary? In that case too, we will take the same approach as we already have. We'll first split up what information we do have, which is given, and compare it with the piece of information that we wish to find. In terms of what's given, we have the initial velocity u, we have the final velocity v, which happens to be 0, and we have the displacement covered. While yes, we do know that Dr. Sal is decelerating at this stage, we don't really know what that value of deceleration is. So we can't yet present it as information that's given. What we need to find, however, is the time duration t. Specifically, the time duration of this deceleration. There's only one equation out of the four that relates s, u, v, and t, which is s equals half times u plus v times t. So now it's just a matter of plugging in the relevant numbers. We have 100 meters equals half times 50 plus 0, that's u plus v, times the time duration that we wish to find, t. Now it's just a matter of rearranging this form equation. So we multiply 2 on both sides to get 200 equals 50 times t. Divide 50 on both sides and we should get 200 divided by 50 equals t. Simplifying this further, we will get 4 seconds. So in short, Dr. Sal will take about 4 seconds to decelerate from 50 meters per second all the way to a final velocity of 0 meters per second. Great. Let's go to the next question where we'll revisit Tufi once again. Suppose Tufi is once again standing on this racetrack, and suppose he's ready to run a specific race, in which case he starts off this race from rest, which means that his initial velocity is 0 meters per second, and he maintains a constant acceleration of 6 meters per second square, because of which he eventually reaches a maximum velocity of 9 meters per second. The question is that during this portion of uniform acceleration, how much displacement has he covered? Once again, we'll split up all the information we do have, which is given, and compare it with the information we wish to find. In terms of what's given, we have the initial velocity u, because we're told that Tufi starts his journey from rest, which means, in other words, that his initial velocity is 0. He has a constant acceleration of 6 meters per second square and a final velocity of 9 meters per second. And what we wish to find is the displacement, the only one equation that relates initial velocity u, acceleration a, final velocity v, and displacement s is 2as equals v square minus u square, because it's the only equation that doesn't contain any inclusion of time t. And so it's just a matter of plugging in the numbers. We have 2 times 6 times s equals 9 square minus 0. Simplifying this further, we get 12s equals 81. Then s is simply 81 divided by 12, which simplifies further to 27 over 4, which further simplifies to 6.75 meters. And so we realize that during the time that Tufi runs this race of first starting from an initial velocity of 0 all the way to reaching a maximum velocity of 9 meters per second, he covers a displacement of 6.75 meters. Alright, now let's look at the next question where we'll encounter Dr. Sal and his trolley once again. Suppose he's on his way, seated in his trolley as per usual. And suppose due to a series of some unfortunate events, he encounters some kind of a blockade or an obstacle which alarms him. So much so that he presses on the brakes at this point. Because of that, he is going to uniformly decelerate, which is to say that he'll have negative acceleration. Suppose that negative acceleration is 2 meters per second square. And with this uniform deceleration, suppose he stops at this point. Now, as soon as he stopped, suppose he has covered a safe distance of about 100 meters. Let's call that displacement s. Now, if I wanted this slowing down process or this deceleration to occur in a time of about 10 seconds, my question then is, what should have its initial velocity been? In this case, we merely write down all the information we're given. In this case, we're given the deceleration, we're given the time t, and we're given the displacement. And what we wish to find is the initial velocity of the trolley and Dr. Sal combined. The one equation that relates a, t, s, and u is simply s equals ut plus half at squared. So now it's just a matter of plugging in the relevant numbers, in which case we get 100 equals u times 10 plus half times minus 2 times 100 squared. Simplifying things, we get 10u. Notice how I include the negative sign because I have deceleration involved. So the negative sign should be included there. And I get 100. Adding 100 to both sides, I get 200 equals 10u. Divide 10 on both sides. And I get 20 meters per second. So this goes to show that if Dr. Sal wishes to decelerate safely within 10 seconds while at the same time cover 100 meters, his initial velocity must be 20 meters per second. Great. Now let's wrap things up with one final question of both Dr. Sal and Tufi racing each other together. So this is basically a type of question that we encounter many times in AS level physics. So it's good to just know how we can conceptually go over such a question so that when you get different variations of the same type, you'll understand how we can encounter them and deal with them when we see them in past papers. So the scenario is quite straightforward. Suppose you have Dr. Sal, who's already in motion at a constant velocity of 10 meters per second. And suppose as he's moving along, he moves along this starting point where Tufi is standing initially at rest. As soon as Tufi sees Dr. Sal move past him, he initially starts moving as well. And as soon as he starts moving, he maintains a constant acceleration of about 2 meters per second square. And he continues to do so until he's ready to overtake Dr. Sal. Suppose by the time they both overtake each other, they have reached this point. So Dr. Sal is over here with the same velocity of 10 meters per second, and here's Tufi with some new value of velocity, still going forwards. And this is the dotted line at which point Tufi has overtaken Dr. Sal. Now the question is this: how long does it take for Tufi to overtake Dr. Sal? Now here the whole idea in how we solve this question is to understand what does it mean for one person to overtake the other. Physically speaking, it just means that one has basically caught up to you. So if I were running forwards and you were catching up to me or overtaking me, it would mean that you would have to cover any remaining distance that there was behind me and then go forth, or at least at the very least you reach the same point as I have in terms of position, right? So if you imagine Tufi overtaking Dr. Sal, that would require Tufi to cover the same distance as Dr. Sal has, or displacement in this case. So this is a very important thing to conclude over here, and I'll in fact write it here as well. The point where Tufi overtakes Sal or Dr. Sal is the point when Tufi and Dr. Sal both cover equal displacements. So now it's just a matter of figuring out two expressions, one for the displacement that Dr. Sal covers and one for the displacement of what Tufi covers. What we'll do next is we'll basically construct two equations where we'll have time t as the unknown, and it's just a matter of solving these equations simultaneously to then evaluate a value of time. So let's first get our expressions for displacement. Dr. Sal's displacement is the easiest to evaluate simply because he's moving with constant velocity. And there's but one formula we can use for constant velocity, which is displacement covered per unit time. It's just a matter of rearranging this to get an expression for displacement, which would be velocity multiplied by time. Since his velocity is 10 meters per second throughout, this will simply be 10 times t. So that's our first equation, and I label it 1. Next we have Tufi's displacement. Now to figure this out, we have to first see what information we do have and then figure out what information we need to find. Now what we do have is the initial velocity u, we have his constant acceleration a. While we don't know what his final velocity is, I do wish to construct an equation that contains a symbol for time t as well. So I should include that as my given information as well. What I need to find is an expression for displacement. The one equation that contains u, a, t and s is simply s equals ut plus half at squared. As tricky as this looks, the first term actually vanishes because our initial velocity is 0 and any number multiplied by 0 is simply 0. So we can simplify this to half at squared. I can plug in the value for acceleration, which is 2 meters per second square, and I get half times 2 times t squared, which is simply t squared. That is my second equation. Now it's just a matter of equating these two expressions for displacement. So now we're merely equating 1 and 2, and what do we get? We have 10t equals t squared. If we divide t on both sides to simplify things, we arrive at a value of time t which is equal to 10 seconds. So in short, it takes about 10 seconds for Tufi to overtake Dr. Sal. Great. So not only have we learned how to apply different equations of motions to different kinds of scenarios, but we've also understood one type of question that we encounter a lot in AS level physics, which is the description of one moving object overtaking another. And so at this point, I'm sure that you are quite comfortable with knowing all of your equations of motion, and moreover knowing which equation to use when. Thank you.